All right. Today we'll be going over the T28B digital multimeter. My name is Josh Bang, and I'm in charge of the introduction and safety portion. So, meet the digital multimeter. It is an essential tool for understanding electricity. So, what does it do? It basically tells you what's going on inside a circuit, if my circuit is even working, and if not, why. It gives you measurement values that does not leave you guessing. So, what exactly does it do? It measures voltage, current, and resistance. These three measurements are related through Ohm's law, which is shown in the picture to the right, and this one tool solves all three of these issues. So some features that it has is high voltage measurement range, portability, an LCD screen, non-contact voltage detection, and is beginner friendly. So this multimeter is built for learning, but also the real world use. Some safety risks that come along with this include the electric shock risk, overloading the tool, and if you use the multimeter improperly, you can blow fuses, damage the tool itself, and you should always check probe condition before using it. So the rule of thumb is to verify settings, inspect equipment, and follow safety rules. Some tips to avoid those risks include avoiding live circuits, so that's not touching your hands on bare wire, turning off power when measuring things like continuity and resistance, using proper settings, and following electrical procedures. And these are my references.
Hi, my name is Vaibhav Shintre, and I'll be talking you through the multimeter description and the list of materials. So, what exactly is a multimeter? It's a handheld instrument used to measure electrical properties, and it combines multiple measurement functions into a single portable device, uh, making it one of the most essential tools in electrical and electronic work. So, how does a digital multimeter work? When you touch the probes to a circuit, the signal doesn't go straight to the display. First, the incoming signal passes through protection circuitry to prevent damage, then through a voltage divider which scales it down to a safe level. From there, the signal goes to the analog digital converter, or the ADC, which takes the raw analog signal and converts it into a digital number that the microprocessor can read and display. It does this by charging a capacitor with the input signal and measuring how long it takes to discharge, a process called dual scope integration. Finally, the microprocessor takes all of this data, applies calibration corrections, and displays a clear, precise reading on the screen, all in a matter of milliseconds. So the multimeter can measure voltage, current, and resistance. But how does it measure these key properties? The ADC can only read voltage. For current, the signal passes through a shunt resistor, which creates a small voltage drop that the ADC can measure. It does this through Ohm's law, which relates voltage, current, and resistance. For resistance, the multimeter sends a known current through the component and measures the resulting voltage. Where are multimeters used? Multimeters are used widely for their portability. Electricians rely on them to diagnose wiring issues and verify outlet voltage. Automotive technicians use them to test batteries. Electronic and repair professionals use them to test circuit board components. They are a standard tool among students and professionals alike. For the external materials, the LCD display is used to show precise numerical readings. The rotary selector dial is used to choose the measurement type. The input jacks are ports where the test leads connect, and the test probes are two insulated leads with metal tips which are used to contact a circuit. For the internal materials, the PCB and analog to digital converter act as the brains of the multimeter. The battery powers the device. The fuse protects the instrument from excess current, and the resistors and capacitors support accurate measurement readings.
Hi, my name is Jacob Wilson. I'll be discussing how to use a multimeter and then later the conclusion as well. Multimeters are capable of doing a variety of things, but the highlight today will be understanding voltage and current, as well as testing a variety of circuit components. The first step is to ensure the probe leads are connected in the correct way. The Black probe will always be placed in the COM jack, while the red probe will typically stay in the far right jack unless dealing with current. For measuring voltage, set the dial to V and select a range. The range selected must be greater than the expected voltage, otherwise the reading will cap out and be inaccurate. Finally, touch the probes to the component you wish to measure the voltage across of. The red probe is positive while the black probe is negative. This determines the polarity of the voltage or which way the associated current is flowing. If the display reads negative, swap the probes. Voltage can be measured while the circuit is running, but it's very important to turn the circuit off when measuring current. Current requires you to break part of the circuit open, as the multimeter will complete the circuit itself in series. Ensure the black probe is still placed in the COM jack and the red probe is placed in either the milliamp or 20 amp jack. The decision on which to use should be based on the power supply. If a lot of current is expected, use the 20 amp. Otherwise, for breadboard applications, the 20 milliamp jack is fine. Again, adjust the dial and exceed the maximum expected current. Place the probes on the open circuit connection and turn the power back on. This will allow current to flow, giving an accurate reading. The qualities of components can also be tested, such as the resistance of a resistor. Resistors have their specified resistance placed on their body using a banded color code system, but the specified resistance may not match the actual resistance due to tolerances. To test a resistor, remove it from the circuit and turn the dial to the ohm symbol. Touch one lead with the red probe and the other with the black probe. The display will show the actual resistance of the resistor. Always double check your resistance values to ensure your circuit will behave as intended. A good resistor will be within plus or minus 5 to 10% of its printed value. Capacitance of a capacitor can also be tested. Discharge the capacitor by touching its leads together to short them and turn the dial to the capacitance symbol. With the probes properly connected, touch one probe to each of the leads. The display will then read out a value, typically in micro or nanofarads. Compare this to the label on the capacitor itself. A good capacitor will fall within plus or minus 20% of its rated value. Diodes are another thing that can be tested. First, remove the diode from the circuit and ensure the probes are placed in the correct jacks before turning the dial to the diode symbol. Place the red probe on the anode or positive end and the black probe on the cathode or negative end. A good diode should read within 0.5 to 0.8 volts. If the display shows OL, that means that the current isn't flowing, and that means the probes are on the wrong side. Swap them and remeasure. And then here are my references.
Hi, my name is Garland May, and I'll be covering the troubleshooting section, which is the process of finding and fixing problems in a circuit. A multimeter can be used to help measure voltage and test continuity to locate issues. I'll be walking through a simple step-by-step method to diagnose common circuit problems using the tool. Troubleshooting is needed when a circuit doesn't work as expected. This includes no power, incorrect readings, overheating components, or inconsistent behavior. These signs indicate something in the circuit is not functioning properly. The process follows a clear order. First, check the power source. Next, verify the connections, then measure voltage, test continuity, and identify faulty parts. Following this order helps find problems faster. First, confirm the circuit is receiving power. Set the multimeter to DC voltage and measure the source. If the reading is 0 or too low, the issue is likely the battery or the power supply. Next, verify all of the connections. Look for loose wires, incorrect wiring, or visible damage. Some connection issues are common, yet a simple cause of failure. Measure voltage at key points in the circuit. Place the black probe at ground and red probe at the test point. Compare the readings to the expected values. Low or missing voltage helps locate the issue. Continuity testing checks if current can flow. Set the multimeter to continuity mode and place probes across a wire or component. A beep means a complete path, while no sound means a break. Make sure the power is off as to not damage the tool. Now isolate the problem. Measure the voltage before and after components. A voltage drop suggests a failed component, while no voltage past a point suggests a break earlier in the circuit. Common issues include no readings, which is often caused by a dead battery or wrong multimeter settings. Fluctuating readings usually come from loose connections. No continuity indicates a broken wire or component, and these can be fixed by adjusting settings on the multimeter, securing connections, or replacing faulty parts. And here are my references.
In conclusion, multimeters are essential tools when working with electronics. electronics. It is important always to keep safety in mind when working with electricity and to use the device and components only as intended. Multimeters can measure voltage and current as well as components qualities such as capacitance or resistance. Troubleshooting circuits with a multimeter should follow these steps. Check the power source, verify connections, measure voltage, test continuity, and identify faults. We hope we have provided you with useful information today that makes it easy for anyone to jump into the world of electronics. Thank you.